After all the knowledge that we have learned so far in calculus, we are ready to graph a function using calculus. So let's take a look at this example. F of x equals 2x over square root of x squared plus 2. In order to graph a function, we have to determine the domain first. And the domain for this function, if we take a look, well, it's a fraction, so the denominator cannot be 0. We have a square root, so whatever is inside the square root is non-negative, okay? But because it's in the denominator, it has to be greater than 0. Now, if you take a look at this x squared plus 2 is greater than 0, you know that it's always true because a square plus 2. So, or in another word, all real number will work for this inequality to hold. So the domain is negative infinity to infinity. Next, we talk about the intercept. So when you plug in x equals 0 to find the y-intercept, you get 0, 2 times 0 divided by square root of 0 squared plus 2. So that equals 0. Okay, so the y-intercept is 0, 0. We solve for y. Now, the x-intercept, to find the x-intercept, we set this 2x, the function equals 0, and solve for x. So we multiply both sides by the denominator, we get 2x equals 0. Therefore, x equals 0. So the x-intercept is also 0, 0. Next, we want to see, do we have any kind of asymptote? Well, first of all, there's no vertical asymptote. The reason is because the domain is negative infinity to infinity. Now, to find the horizontal asymptote, we have to take the limit as x goes to infinity of the function. You might notice that, okay, the net power on the top, the numerator, is x to the first power. The highest power in the bottom is x squared, but then you take the square root, so it's still x to the first power. So we will divide the top and bottom by x. So in that case, we have limit as x goes to infinity. On the top, we get 2. In the bottom, we divide x. X is positive infinity, so it's positive. So we can bring it into the square root function. Okay, so it's just 1 plus 2 over x squared. So as x goes to infinity, 2 over x squared is 0. So it's 2. Therefore, the horizontal asymptote is y equals 2 when x goes to infinity. Now, how about when x goes to negative infinity? Would it still be 2? Not quite, because if you think about the sign, right? X is negative infinity, the numerator is negative, but the denominator is positive. Because you're taking a square root, so the answer must be negative. And it's negative of this absolute value, which is the 2. So y equals negative 2 is the horizontal asymptote as x approach negative infinity. Next, we want to see if there are local mean and local max. Because according to your pre-calculus knowledge, you can already kind of draw this graph, right? So it will look like, okay, intercept as 0, horizontal asymptote as negative 2 and 2. So it has to look something like this. But then the question is, do I have any local mean, local max, any inflection point? So we will need to continue using calculus by taking the derivative of f of x. Now it is a little bit complicated, but we have learned everything that we need to know to do it. So let's get it done. So go back also. This is the function, right? 2x divided by square root of x squared plus 2. So it's a quotient rule. Okay, the derivative of the numerator, which is 2, times square root of x squared plus 2 minus 2x times the derivative of the denominator, which is 1/2 x squared plus 2 to the negative 1/2 times derivative of inner function 2x all over x squared plus 2. Because we square the denominator, we get rid of the square root. Now it is a complex expression, so we need to simplify it in order to easily take the second derivative and also evaluate f prime of x equals 0. So we will first cancel out the 2 and the 1/2. So this is just 2x squared right here. The lowest power here is x squared plus 2 to the negative 1/2. So we multiply top and bottom by x squared plus 2 to the 1/2 power. Okay, to cancel this negative power out. So here, the x squared plus 2 to the 1/2 power is just square root. Okay, so we get, for the first term, it's just 2 times x squared plus 2 times 2, 4. Then we subtract, well, this cancel out, so what is left is just x times 2x, so it's 2x squared times, divided by x squared plus 2 to 1 plus 1/2, 3 over 2 power. So what it is 4 over x squared plus 2 to the 3 over 2 power, or is the same as 4 divided by square root of x squared plus 2 to the 3rd power. So that is derivative. Now, in order to find the second derivative, it is easier to put it into a power form. Okay, so f double prime of x equals a derivative with respect to x of the power form of this is 4 times x squared plus 2 to the negative 3 over 2 power. So use the power rule, we get 4 times negative 3 over 2 times x squared plus 2 to the negative 5 over 2 power times the derivative of the inner function, 2x. And we simplify it to get negative 12x divided by x squared plus 2 to the 5 over 2. Now, in order to find the critical number, we take a look at f prime of x equals 0. But as you can see, okay, it's 4 over something. The denominator is non-zero. Numerator is 4. It can never equal 0. So that's no critical number, so DNE. Because there's no critical number, there will be no local max or local mean, because we don't have any critical number. So that means you will not have any local or horizontal tangent line. So trying to draw the graph without any horizontal tangent line. Now, do we have a point of inflection? So inflection point is f double prime of x equals 0 and the concavity change. So as you can see, okay, if you set f double prime equals 0, it has to be 12x equals 0, right? So x must be 0. Now to verify x equals 0 is indeed an inflection point, we need to discuss a sign of f double prime before 0 and after 0. So let's pick the number -1 and plug it into f double prime. We have negative times 12 times -1, so it's positive, and the denominator is always positive. So we have a positive here, and when we plug in 1, we get negative of a positive fraction, so negative. So it's concave up before 0 and concave down after 0. So we do have an inflection point, and it's 0, 0, because when x equals 0, y equals 0. So you go back to your graph, and you make sure the graph do look concave down and concave up on both sides, just to write out the details. So that will be the final graph of the function.